So far we've talked about graphing and substitution as possible ways to solve systems of equations. Graphing, we graphed both of them to find the intersection, which is the one point, the xy ordered pair that's on both lines, so it's a solution to both functions. For substitution, we put one equation into the other equation to make one big equation that just had one variable in it, and that way we could solve to find the value of one variable. And then we could also take that and find the value of the other variable. Elimination is another strategy that we can use to find the value of one variable. Just like with substitution, we turned two equations into one equation right here. With elimination, we can do the same thing. Now, just like you can add and subtract numbers, you can also add and subtract equations. If both equations are in standard form, especially, it's really easy to do this. Just make sure that your x's are lined up, your y's are lined up, your just plain numbers are lined up, and your equal signs are lined up, and then you can combine the two equations. So here we have 2x's and 5x's, that's 7x. 4y and negative 4y, 4y minus 4y, that's just 0. Those two cancel out. They have the same coefficient, but opposite signs, so they just cancel out. So I'm just going to do that. And then equals 12 and 9 is 21. So now we know if we divide both sides by 7, that x equals 3. So if both equations are in standard form, it's just that simple to find the value of one variable. Just like you can add and subtract numbers, you can add and subtract equations by lining everything up and combining down. Now once you have the value of one variable, you just plug it in to find the value of the other. We have the value of x. And remember, you can plug it into either equation. It doesn't really matter which one. I'm just going to pick the top one because I don't really like negatives all that much. So I'm going to take this x and I'm going to put it right there for that x. So now I have 2 instead of times x, it's times 3 plus 4y equals 12. So that's 6 plus 4y equals 12. Now I just solve for y. So I subtract 6 from both sides. So I get 4y equals 6. Divide by 4. So y equals 6 divided by 4 is 1.5. So that means if I were to graph these two equations, they would intersect at the point 3, 1.5. Now let's try this system of equations here. They're both in standard form. My x's are all lined up, my y's are all lined up, my equal signs are lined up, and my numbers are lined up. This is a great candidate for elimination. The only thing is, up here, our y's canceled out right away because we had a positive 4y and a negative 4y that canceled each other out. Down here, though, we don't have that. We have a negative 3 and a negative 5 for the x's, so they're not going to cancel out. We have a 6 and a 2 for the y's, so they're not going to cancel out. But just like you can add and subtract numbers and you can also add and subtract equations, you can multiply numbers and you can also multiply equations. So what we're going to do is I know that if I just multiply 2 by 3, it's going to turn into a 6. And so then if I multiply it by a negative 3, this would become a negative 6, and then it would cancel out with that 6. So I'm going to multiply this entire equation by negative 3. So now I'm going to rewrite my system. So my first equation is negative 3x plus 6y equals 15. My second equation, I'm multiplying the whole entire thing by negative 3. So now I have negative 3 times negative 5 is 15x. Negative 3 times 2 is negative 6y. equals negative 3 times negative 3 is 9. So I just multiplied this entire second equation by negative 3. Because I knew that if I multiplied it by negative 3, this would turn into a negative 6, and these would cancel out. The hardest part about elimination sometimes is deciding which variable you want to cancel out and what you need to multiply the equation by to make that happen. Here I said I want to cancel out the y's, so I'm going to multiply this by negative 3, so it turns into a negative 6, and these cancel out. Now I can combine. So negative 3x and 15x is a positive 12x. 6y minus 6y, those cancel out now, equals 15, and 9 is 24. So now I know if I just divide both sides by 12, that x equals 2. And once I know what x is, now I can put x into either of these equations, or I could also put it into this equation if I wanted to. I can put it into any equation that I have so far. I always pick one of the original ones though, and I'm just going to put it into the top one, we'll say. So I'm going to say negative 3 and x is 2. I'm going to plug that in. Plus 6y equals 15. Negative 3 times 2 is negative 6. Plus 6y equals 15. So if I add 6 to both sides, I get 6y equals 21. And then if I divide by 6, I get that y is, let's see, 21 divided by 6, that would be 18 with 3 left over. So 18 and 3 6, which is 18 and a half. 18.5. Oh, sorry, 3. 3.5. 6 goes into 21 3 times. See, it's 18 and 3 left over. So if I were to graph those two equations, I would get that they would intersect at the point 2, 3.5. That is how you solve systems by elimination.